Good morning. My name is Lakshman, and this is linear support vector machines assignment, and this is for recognition of hand digits. We have the data set that is given as a multi-class level, which is 0 to 9. So we need to recognize these hand digits, which is given under pixel. So let's say if it is a number, some we have captured the pixels of the handwritten digits, and it is given as a data set for us. So, and in the end we have got labels as 0 1 2 3, likewise 9. Since it's a multi-class level, we will not be able to do a logistic regression so easily unless we need to go multinomial logistic regression, which is not feasible. So in this case, we are testing a multi-class level algorithm which is support to automation. However, we can do this with decision trees, or we can do it with neural networks. But right now we are looking at SVM. Now SVM has got three types: linear, polynomial, and RBF kernel. So here one of the important concept is margins. So margin is the line that will differentiate the classes. It could be two classes or more than two classes, but the maximum margin here is the closest points to the line that we give, that need to be maximum. That means if you draw a line, the either side of the, let's say if there are two classes, either side of the line should have the closest points that will be in the data set to this line are called maximum margins. So so our SVM, if it is linear, it will not consider any other data points other than those points which are very close to this line, and the distance between this line, a perpendicular distance between this line to the closest line, is the maximum margin distance. Now, in this handwritten data points, we have a standard way of looking at this. We remote, we check for NES, we check for outliers, we check for any inconsistencies, so that we will not have any problem while looking into the data. And again, we divided this into transit and test set data sets, and we have applied three kind of algorithms here. One is linear algorithm, and another one is polynomial algorithm, and third one is RBF kernel. So the reason that we are doing three is that we just want, as the model moves from linear to RBF, the model complexity will increase. So there are likely chances that there would be a overfit of the model where the bias variance data would be very much disturbed. But in this case, the linear model is giving somewhere around 91% accuracy, whereas sensitivity and specificity are above 80%, which is very good. And even in the case of polynomial, also it is very close. So if I had to choose between linear and polynomial, I'll choose the linear because it is giving the same accuracy as polynomial, but the complexity is less. But if we come back to the RBF kernel, it is going up to the accuracy of 96%, and the sensitivity is somewhere around 99%. Now, having said all these things, we here we have one of the concept that we called as cross validation, where since doing predicting hand digits, handwritten digits is very unstable. So we need to do a cross validation here, which is very good. So cross validation is, if we say that we do five-fold cross validation, we divide the entire data set into five equal parts. So let's say we have 100 data points, we divide it into 20, 20, 20, 20, 20 into 520s, and the first 20 will be considered as test set, and the rest of the 90, rest of the 80 will be considered as a train set. Likewise, this will move to the next 20 and next 20, next 20. Like this train set will move in from one data set to another data set, and the remaining will be considered as a train set. And this 20% is considered as a test set. And all the time, each time when this train and test set is divided into 80 into 20% respectively, there will be the sampling will be very random, and the algorithm will run on this 5 times, and it will give you the best possible stability of the model, which will give you the stability of the model. And if in all 5 times, if we are getting the right kind of model, we'll get a right accuracy, which is very stable model that we get it. So here, if we check, we'll get a hyperparameter where we will have to check. We'll have to give the hyperparameters like what is the uh, for example, what is the metrics that we need to give here. So see, that will be find it out by the optimal way of hyperparameters for any RBF or polynomial kernel will be identified with this cross validation point. So this cross validation will give you the best fit hyperparameters for this particular model where you get maximum accuracy without going for any sensitivity or specificity loss. So anytime the cross validation check is must for some of the multi-class variables, and I specifically check, though it is very time consuming SVM. We need to check the cross validation time and again before finalizing the results. Otherwise, there is a high severity of overfitting in this model, in this algorithm. So the steps are very standard. We do check linear, polynomial, and RBF, but for all these things, we will go for cross validation to get the optimal hyperparameters for the model that we do. Thank you very much. Have an appreciative time.